in a certain binary communication channel, it's equally likely to send a 1 or a 0, or with both probabilities being equal to 1/2, and the probability of an error given that a 1 is sent is 2/9, while the probability of error given a 0 is sent is 1/9. So when we see something like this is something we want to write out. We want to draw out real quick. So we have the probability that we have a send a 1, right? So we'll just do 1 send. And there's a probability that we send a 0, so I'll call this a 0 send. Now, the probability of this happening for both of these is equal to 1/2, it tells us here. So I'm just writing down everything it's telling us. Now, there's also a probability that our 1 is received, right? So we'll do 1 received, and there's also obviously a probability that we have a 0 received. Now, rereading it again, the probability of an error given that a 1 is sent is 2/9. So that means if we have a 1, right, it should go to the 1, but we have an error and it's sent to the 0 instead. Now, the probability of this happening is 2/9. Now, that means the probability of a 1 going to a 1 is just 2/9 minus 1, or 1 minus 2/9. And that's going to give us 7/9. So that itself is pretty simple. That's a way we can find that out. We're going to do the same exact thing for our 0. So the probability of an error given that 1 is sent is 2/9, while the probability of an error given a 0, so this is our 0, is sent is 1/9. Okay, so that means we're going to go from here to this 1 received. The probability of this happening is 1/9. So that means the probability of a 0 actually going to 0 is going to be 8/9. So that's how we would look at and draw this out. Now we can actually solve this. In solving it, the first thing it asks us for part A is what's the probability that a 1 is received? Well, the probability that we have a 1 received is going to be equal to the following. There's two possible ways we can get a 1, right? Either we have a 1 sent or we have a 0 sent and there's an error. So this is going to be equal to the probability of, we'll do the 1 received, right? These are both going to be 1 received. So the probability that we receive a 1 given that we have a 1 sent. So this is sent to us. And the probability of this happening is going to be basically the 1/2 itself. So it's going to be the 1 send. Plus the probability of, we still have of course 1 received, because that's all we're doing, right? We're just receiving here. Given that we have a 0 sent. And this is the probability of 0 sent. So that's how we would write out this first one. Now all we have to do is plug in the specific values. So we have 7/9 times 1/2 plus 1/9 times 1/2. And this is going to give us 8/18 or 4/9. So that's how we would solve for our A. It's A complete. Now let's look at B. Part B, it says what is the unconditional probability that an error occurs? So we have the probability that we get an error. Well, it's going to be basically the same thing as our first part, except we're changing this from received to error, right? The probability that we get an error. So the probability of an error, given that we were sent a 1, and this is going to be, the probability of this happening is if we have a 1 sent, plus the probability of error, still the same, given we have a 0 sent. And then we have the probability of 0 send. Now, the unconditional part is basically because we're not choosing between the error of 0 or 1. We're combining the error for both of them. So the probability of an error, given that we have a 1 sent in, is going to be a 2/9, right? If we have this 1, it goes this way in error as 2/9. Right, and the probability it gets sent is 1/2, plus we have an error given a 0 send, and the error is going to get a 1, so that's going to be plus 1/9 times 1/2. This is going to give us 3/18. We can write this as 1/6 as well. In part C, we're asked what is the probability that a 1 was sent given a 1 was received. And for something like this, we are going to use a Bayes theorem. Now, you can look in the description below the like button to find the notes that has this in it. Essentially what we're having here is the probability of our 1 being sent given we have a 1 received, right? That's just given to us in the problem. And we're just going to have the probability of the one, if it says probability that 1 was sent given 1 received, probability of 1 sent given we have 1 received, and this is going to intersect or multiply with the probability that we have of our 1 being sent. And this is going to be divided by the probability of our 1 being received. I probably spelled that wrong, but that's the general gist of it. If we have 1 sent and then 1 received, it's going to be 7/9. So this is equal to 7/9 times the probability of sending 1, which is just 1/2. And the probability of receiving a 1 is going to be the 7/9 plus this 1/9. That's going to give us an 8/9. We can rewrite this as 7/9 times 1/2 times, flip this over, 9/8. We'll divide these two, and so we are just going to have a 7/16. And that's how we would go about looking at this specific problem and all the ways we go about doing it.